Assalamu alaikum. The lesson today is about inequalities. So we are going to give in introduction to the inequalities. And show you how to draw the solution of inequality in a number line. So first, let's define what is inequality. So let's go give a definition. So inequality, in fact, is an assertion of two unequal expression. Inequality is an assertion of two unequal expressions, and the definition is totally clear. So it's just a statement which is we don't know if it's true or false. This is what we use the word assertion, because assertion means a statement which is doesn't have a true value if it's true or false, of two unequal expressions. So we have two expressions that are not equal. So let me give you an example. So for example, I can have 7 is less than 9. This is true, so this is inequality. I can have 2 times 5 is greater than 49, which is a false statement, but still is an inequality. Or I can have, for example, 3x minus 9 less than 11, which is something I don't know if it's true or false. So this is undecided, so still is an inequality. So this is exactly what the definition says. It just an inequality between two unequal expression. Those two are unequal, and you have an inequality sign between them. So this called an inequality. The same thing here and the same thing here. So this is why we have different type of inequality. So there are different type of inequalities. So we're going to talk about the type of inequality. Of equality. What is inequality? It is an inequality that is always true regardless of variable. So it's identity inequality is an inequality that is always true regardless the value of the variable. So regardless the value of the variable. So let me give you an example so at least you see the idea. For example, 3 is less or equal than 11. So this is true, even though we have no variable, but this is an identity inequality. X plus 5 is less than x plus 7. This is always true, regardless the value of x we put. If I choose x, if I, or you can have 0 is less than 1. So this is the true statement. But when we apply This is we should conclude your statement of inequality. We always conclude all number of solution because I prefer to use odd number here because to make clear that any number will work, not a specific number. So we'll see what as all mean we don't exclude any number. Our solution is the conclusion you should conclude when connection inequality. Is an inequality that is always false regardless of the value of its variable. So contradiction inequality is an inequality that is always false regardless of the value of its variable. If there is any. So for example, 2 is greater than 7, x minus 5 is less or you see all of them are false statements because 2 is x equals to 15 is greater than 20. You see, it makes no sense. So this is a false statement, and this again is so in this. So this type of inequality conclude by no solution. Inequality. Uh, an inequality that is true only for a specific number of value of the variable. So conditional inequality is is an inequality that is true only for a specific value of the variable. So, for example, x plus 7 is less than 16. So this, so we'll get 18, so 18 cannot be less than 16. But if I choose, for example, 8, so any number for me. Again, if I have, for example, greater than 1, so this true, all 5 third, 5, 11, 4, which is 29, is 1. But if I choose, for example, cannot be greater than 1. If I choose x equal 1, you see I will have to. So this type of solution has a set of solutions. This type of solution learn how to draw the solution of inequality and of inequality as this is the medium. Most of the time, inequality have this inequality in a number line. So of inequality in number line. So in order for you to draw the solution of inequality in number line, so you need to understand one thing. When we have a number line, what do we have? We have the left and the right. You see, you have to understand this. I will not draw 0 or anything here. We have the left and the right. So we have the left and we have the right. And always the right is bigger than the left. This means always the right is greater than left. So for example, if I pick 1 here and I pick 2 here, you see 2 is greater than 1. Or I pick 12, 12 is greater than 1. And 1 is less than 12 because 1 is on the left side of 12. 1 is on the left side of 12, so it's going to be less than 12. 12 is on the right side of 1, so it's going to be greater than 1. So greater mean on the right side of that number. Left mean it's smaller. So you have to decide is that number should be on the right or on the left. For For example, x is going to be on the right or on the left. So it depends how you notate this. For example, if I say x is greater than 2, you see 2 is less than x. So if I read this from left to right, I write x is greater than 2. Where is the number greater than 2? Is on the left side or on the right side? Anything greater than a number is always on the right side of that number. So any number, any uh, number, for example, any number greater than, for example, a number n is on the right side of n, is on the right side of n. So x is greater than 2. That means x should be on the right side of 2. So if I draw my line here for this statement, so this is my 2. It can be anywhere. So this is minus infinite, this is infinite. So where is the location of x? Is greater than, this means on the right side. Where's the right side of 2? This is the right side. That means we shade that part. If I say x is less than 5, or I say 5 is greater than x. You see, those two statements mean the same thing. But my advice to you, always read from the variable, because when you read from the variable, it will give you the right place to shade. When I read from here, for example, from the variable x, x is less than 5. That means x is on the left side of 5. X is greater than 2. That means x is on the right side. You see, just connect left, greater and less with the right and left. Greater mean you go to the right. Less mean you go to the left. So here, if I read it from my left side here, so x is less than 5. Here, if I read it from this x, x is less than 5. So in my number line, when I draw it, you see, I connect less with left because left, greater right. So I just do what I put my 5 here, and I say x is less than 5, whereas the left is on the left side. So then I shade the left side. So just connect greater, that means the right side. So less than m is on. This is how I want you to see it. This is for the shading part. Which part you choose on the left, on the right? Always look at the variable and look at the sign next to the variable. Read it from there. It's like less than 5 side. So this is the place where I will go into shade. So the second type, the second the second thing to do with the drawing is when we have less than, so what we do, or greater than. So when we have less than, for example, if I have x is greater than 5, so in my number line, what I do 5 here, and I put an open circle. What does mean open circle? That means it's not full, that means it's just a circle around the 5. This means that I include any number greater than 5, but I don't add 5 with my solution. That means we exclude 5 from the solution. This means we exclude 5 from the solution. That means if I want to pick an x value, So I pick something greater than 5, but I don't pick 5. I pick anything greater than 5, but I don't pick 5. That's mean because this, it means that it's greater than. That's mean it's not equal to 5, and I cannot pick 5. So that's the idea behind this open circle, and this is the idea behind greater than or less than. So in any way, so even if you have 5 is less than x, because those are the same thing. So this is not include 5 in the set of solutions. So when we shade, we put an open circle on the number that we have on the side of this inequality, and you put an open circle on it because we don't include it in the solution. So this is for those case if I have that type or that type. So mean, what does mean here? When you have that type, it's mean it's less than or equal. That means we have the choice that they can be equal. You see, it can be equal. X can be equal. That means if I have x is less or equal than 2, it means x is less than 2 or x is equal to 2. So that means x may be equal to 2. So in my number line, what do we do? I choose my 2, but I fill the circle. By filling the circle, I mean I include 2 in my set of solution. So here, this means include 2 in the solution. So if I have x is less than, so this is the left side, and 2 is part of the solution. So this is how we draw the solution of an inequality after we solve it. So I hope you understand the concept behind this introduction of inequality. So I hope that you understand the idea behind. So we're going to use all that concept in the coming lesson. So please understand it. So we are going to use it. And if you have any comment about the way I teach, so please do so. It will help me improve my way of teaching. And thank you for watching the video. Assalamu alaikum.